Hello students, so let us continue this time with the Arrhenius theory of electrolytic dissociation. Arrhenius theory of electrolytic dissociation. So this is something now the scientists are observed that now electrolyte when dissolves in water they ionizes or no they dissociate each other and they exhibit a mechanism like conductivity. So different scientists carried out different work and based on their observation they proposed some theory. So let us discuss what is Arrhenius theory is all about. Based on his observation, he has some points to say. What are they? Let us check. First, electrolytes which dissolves in water, it dissociate into electrically charged particle that we can call ions. Electrolytes, electrolytes are dissociated. Electrolytes are dissociated into electrically charged particle. Electrically charged particle called ions in aqueous solution. So this was the first one. Electrolytes are dissociated into electrically charged particle that we call ions. Generally a positively charged ion and negatively charged ion. So simply we can say electrolytes dissociate into cations and anions in an aqueous solution. So that was our first point that he proposed. Next, the dissociation occur only in such a manner that the total charge of the positive ion is equal to total charge of the negative ions. So the whole solution become neutral. So look at the second theory. Total charge of the solution. Total charge of the solution is 0 because equal number of positive and negative ions. Positive and negative ions are forming. One second. So equal number of positive and negative ions are forming. That means now if for example 8 number of positive ions is forming, that means 8 number of negative ions will be also forming. That means now even though charged particles are forming, the whole solution are neutral in nature. So next one, at finite concentration, the electrolyte will be partially ionized to a degree depend on the nature of the substance, the concentration and the temperature. So that's the next point. At finite concentration, electrolytes are partially ionized. Electrolytes are partially ionized. To a degree that depends on nature of the substance. So the ionization depends on nature of substance, nature of substance, and the temperature and concentration. Temperature and concentration. Now this is the one theory that now we you have to look at carefully, because now according to him at finite concentration electrolytes are partially ionized. So now as we already studied this, now this only works for weak electrolytes, because now we know weak electrolytes are partially ionized while strong electrolytes are now completely ionized. So this theory actually now this proposal from Arrhenius actually mainly works for weak electrolytes, because weak electrolytes we already know it's partially ionized, and when the concentration decreases, that means dilution increases, what will happen? The degree of ionization increases. So that's fair point. Then temperature, that also another observation, as the temperature varies the conductivity also varies, because the ions can move more faster. And also another point, nature of the substance. So if the ions are completely ionized, we can say strong electrolytes. If the ions are weakly ionized, if the electrolyte are weakly ionized, then we can say it's a weak electrolyte. So now he, according to his point, even the strong electrolytes are partially ionized in solution. So that that's not accepted point. But that point is very works for weak electrolyte, because weak electrolytes are partially ionized in the finite concentration. But we observe that for a strong electrolyte, even at a moderate concentration, it is completely ionized. So please remember this Arrhenius theory correctly work for weak electrolytes. Next point, the ions and the ions formed from the partial dissociation are in a state of dynamic equilibrium. Fourth point, the ions and the unionized molecules are in a state of dynamic equilibrium. For example, you can represent like this: acetic acid, which is a weak electrolyte, which is now undergo partial dissociation to form acetate ion and H plus ion. Now here you will see, yes, they forms ions in aqueous solution, only partially, but still ions are there, and the ions and the unionized molecule are in equilibrium each other. The equilibrium is also dynamic in nature. What do you mean by dynamic? Because the forward reaction and backward reaction, rate of forward reaction and the rate of backward reaction takes place simultaneously, which means yes, they are in equilibrium and they are too in a dynamic equilibrium. So the concentration of acetate ion or H plus ion do not going to increase. The concentration of the acetic acid do not going to further decrease. That state you can say an equilibrium state, because both forward and backward reaction take place simultaneously at the same rate. So that was the next point related to Arrhenius theory of electrolytic dissociation. Next point, the extent of ionization varies with the concentration becoming greater with the increased dilution and reaching a maximum at a very high dilution. That we already know the at infinite dilution, at infinite dilution, electrolytes are completely ionized. Electrolytes are completely ionized. and they show maximum conductivity. Maximum conductivity at infinite dilution. So, as the concentration decreases, as the dilution increases, you can say the degree of ionization increases, and it reaches to a maximum value at infinite dilution. The ions are free to move and independently under the influence of an applied electric field. Positive ion moves to the negative electrode and negative ion moves to the positive electrode. That's something that you will observe when an electric field is applied. When an electric field is applied, the ions which are dissociated, move to the respective electrode. The electrode which connected to the positive terminal, that we will call anode, and the electrode which connected to the negative terminal, that we will call cathode. So here you can see the cation, positively charged ions, will move to the cathode, which is negatively charged, and negatively charged ions moves to the anode, which is positively charged. So respective movement of ions to the respective electrode. When electricity is passed through it, you will see such movement of ions under the applied electric fields. So what you can write? At an applied electric field, the ions are moves towards the respective electrode. Anion moves to anode, cation moves to cathode. That's the next one. Next, the conductance of electrolytic solution is due to the migration of the ion toward the oppositely charged electrode, and greater the ionization, greater the conductance. This point we already know. No, because ions are moving. Because of the movement of ions, the conductance possible. So, it is when movement of ions or migration of ions to the respective opposite electrode responsible for the conductance. The conductance of an electrolyte is due to the movement of ions in an aqueous solution. And greater the ionization, greater the conductance. Here you can remember, when electric field is applied, a cation will move to cathode and anion moves to anode. So the electrolytic conductance always proportional to the how much it is ionized. That's the point you can remember. And when electric field is applied, you can see the ions are moving to their respective electrode. Next, with respect to the colligative property, the ion acts in the same manner as an unionized molecule. Now, colligative property is something now that we study in solution chapter. That is now, this is the property which depends on the number of moles of solute. For example, elevation of boiling point, depression in freezing point, and now one more property is what is that? Lowering of vapor pressure, osmotic pressure. These are the colligative property that we are talking about. Okay, when a solute is a non-volatile solute is added to a particular solvent, the boiling point found to be increases, the vapor pressure is lowered, and the freezing point also lowered, and there is a variation in osmotic pressure as well. So it all depends on all these colligative property relative lowering of vapor pressure, and next property that we can say, elevation of boiling point. These all are colligative properties. It depends on the concentration of electrolyte. That what now colligative property is all about. So colligative properties found to be showing some abnormal values. That's simply because an electrolyte, no, for example sodium chloride, which dissociate into Na plus ion and Cl minus ion. This is what you observe in aqueous solution, they dissociate. So rather than now 1 mole of an NaCl, here you can see now effectively 2 moles of substance. Generally we can say, because now 1 mole of NaCl dissociate into 1 mole of Na plus and 1 mole of Cl minus. So effectively the concentration, concentration of the electrolyte increases in solution, because now we're talking about 1 mole of an NaCl, we expect the property related to 1 mole of an NaCl, but it's not found. So you can see it dissociates into independent ions, which means now both cation and anion can contribute to the colligative property. That will make change in the colligative properties as well. So please understand that particular point, where now electrolytes are dissociated into cations and anions, and they independently contributing to the colligative property. The cations and anions of an electrolyte contribute independently to the cations and anions of an electrolyte contributing independently to the colligative property. Okay. Next, last point, the property of electrolytes in solution are in the properties of the ions they furnish. Okay, this is something now we know acids behave like an acid because it dissociates into H plus ion. Base is also behaves because it dissociates into OH minus ion. This was Arrhenius theory. So why some substance behaves as an acid? Because they release H plus ion in aqueous solution. Similarly, why some substance behave like a base? Because they release OH minus ion in aqueous solution. So the point is now why some substance, the properties of the electrolyte in solution, and they behaves like an acid or a base, simply because the kind of ions they furnish in aqueous solution. Acids behaves as acid because it releases H plus ion, and other substance like base behaves like having that basic property because it releases OH minus ion in solution. So these are the points which is pointed out by Arrhenius theory. So let us discuss one by one. First one, electrolytes which are dissociated in water to form positively charged ions and negatively charged ions. We can call them as ions in aqueous solution. They form electrically charged particles like cation and anion in aqueous solution. Second point is the dissociation occur in such a manner that the total charge now become equal to 0. So total charge of the solution always remains 0, because the number of positive ions will be equal to number of negative ions. Next point, at finite concentration, electrolytes are partially ionized. Now that's something we can only understand in terms of weak electrolytes, because weak electrolytes are partially ionized at moderate concentration, and the degree of ionization increases on dilution, and it depends on temperature and the nature of the electrolyte as well. Next point, now extent of ionization varies with the concentration becoming greater with increased dilution. As the dilution increases, the extent of ionization also increases. And in a when electric field is when electric field is applied, the cation moves to cathode and anion moves to anode. So in an electric field, the ions are moves to their respective electrode. That's the next point. And the conductance exhibited by these ions always directly proportional to the amount of ions, which means no cation, higher the number of cations, higher the number of anions means no greater the ionization, greater will be the conductance. The next property, colligative property. Colligative property is something that now we will say the property which depends on number of moles of solute. So in the case of an electrolyte, they dissociate into ions, which means no both cation and anions are independently contributing to the colligative property. So when you talk about colligative property, you have to consider the dissociation of an electrolyte to the respective electron. Finally, no, some behavior of a substance like acids and base behavior you can explain through no, this dissociation of an electrolyte in an aqueous solution. Why acid behaves like an acid? Because it releases H plus ion in aqueous solution. Similarly, why base? Because it releases OH minus ion. So that's the point now related to Arrhenius theory. And Arrhenius theory can able to explain now the following mechanism like electrolysis. Yes, there are some limitations are there, but now let us discuss first the positive outcomes of Arrhenius theory. Arrhenius theory can able to explain the phenomena like electrolysis. Electrolysis. Now, what that process is all about, we know when electric field is applied, ions are separated and ions moves to their respective electrode, and you will see no the ions getting discharged at the respective electrode. For example, when a sodium chloride is no molten sodium chloride is no electrolyzed, when molten NaCl are electrolyzed, you can see what will happen. Na plus and Cl minus ions are there in aqueous solution. Cation moves to cathode, anion moves to anode, and they getting discharged. That what no electrolysis is all about. At cathode, what are you going to get? You're going to get sodium metal, Na plus ion, cation, at cathode. Electrons are gained. So by gaining one electron, sodium metal is forming. This is something now the one of the best method of preparation of sodium. It's not easy to prepare sodium. So no, we actually talking about no some substance are forming by electrolysis like sodium metal is forming at cathode. So why it's so? Because no the ions are dissociated in aqueous solution and the ions positively charged ion moves to cathode and negatively charged ion moves to anode and you're getting new substance. Remember Na plus ion and Na are entirely different. Sodium ion do not have any kind of character like sodium. Sodium is highly reactive where Na plus ions are they easily dissolve in water. There is no reaction with water. So you actually getting sodium metal at cathode at anode. Talk about at anode, what will happen? Cl minus releases electron at anode to go to get chlorine atom, and chlorine plus chlorine gives you chlorine gas. So you will see chlorine gas is liberating at anode and sodium metal is depositing at cathode. So the electrolysis phenomena can be explained by Arrhenius theory. Next, increase in molar conductivity with dilution. That's something that we already discussed. Increase in molar conductance with dilution. We saw Walrash's law, everything. Where electrolytes are completely ionized at infinite dilution. So as the dilution increases, the molar conductance increases. That's something associated with the more number of ions are getting separated from each other, or more number of ions are ionized. more number of electrolytes are getting ionized as the dilution increases. Next, ionic reactions. Ionic reactions. We know when sodium chloride is treated with silver nitrates, silver chloride will be formed and sodium nitrate is also forming. So this is the case now. Why no silver chloride is obtained? Because now in aqueous solution sodium chloride dissociate into Na plus NCl minus Ag plus and NO3 minus. So now a cation can combine with an anion and silver ion can combine with the chloride ion as well to get the respective products. So ionic reactions, no, we know they dissociate into ions and both cations and anions are combined each other to give respective products. So silver chloride is obtained by the ionic reaction between sodium chloride and silver nitrates. First, next, no, abnormal values in colligative property. We know delta TF. Let one example: depression in freezing point. That is now proportional to, always proportional to molality of the solution. So delta TF is equal to Kf into M, where Kf is a molar freezing constant, molar depression freezing constant. So this is the case where now delta TF always proportional to M. We know what is M is all about. M is equal to Kf into W2 by M2 into 1000 divided by W1. This is the equation that you can remember for molality. W2 is the mass of the solute, M2 is the molar mass of the solute, W1 is the mass of the solvent. So using this equation you can find delta TF, that is no depression in freezing point. Where now one of the application of colligative properties, you can find the molar mass of the solute. For example, a solute is added, we doesn't know the molar mass, you can find the molar mass of the substance using this equation delta TF is equal to Kf into M, where M is the molality. Molality means number of moles of solute per kilogram of the solvent. So you can find the molar mass. But now the molar mass obtained by using these colligative property values are found to be abnormal, because there we considering 1 mole of a solute, okay, where we saw in aqueous solution they dissociate into ions, which means now not the 1 mole of ions actually existing, actually 1 mole of cation and 1 mole of anion, both are existing, which means definitely that will make a change in the colligative property, that we will call abnormal molar mass everything. So that you will study in the solution chapter. So these are the properties which can be explained by Arrhenius theory. So now this postulate is something that you can now write it down and read and understand different scientists proposing different theories. So one key point you can remember about Arrhenius theory, this really works for weak electrolyte, not that much working for a strong electrolyte. That we will discuss in the next class, what are the limitations of Arrhenius theory. Okay, thank you.